Okay, everyone, welcome to Green Newton and Historic Newton's program, uh, Heating and Cooling Older Homes for Comfort and Energy Efficiency. This program will be helpful, particularly if you have an older home that needs heating and cooling upgrades, or if your old heating system struggles during cold weather, or if you want to add air conditioning. Our first presentation, I'm going to introduce all three speakers, and there will be an opportunity to ask questions. Please note that this program is being recorded, and you can ask questions in chat, or you can send them to heatsmartnewton@gmail.com. This is a public meeting, and the chat transcript will also be recorded and considered a public record. So you can read the disclaimer here about that we are recording this program. You can hide your video, and everyone is muted anyway. I want to point out before we move on that Green Newton has a program called the 4C Tree Program. We are fundraising for a project to plant trees in Newton to honor lives lost to COVID. And we actually raised enough money to plant 170 trees from the people lost in 2020. And we need there are other costs involved, like the cost of watering the trees. And we want to plant additional trees in the fall of 2021. So if you'd like to learn more about this project or donate for the planting of trees, please visit greennewton.org. And now I'm going to introduce all three of our speakers. If you have questions, remember you can put them in the chat function. We'll be saving questions. If we don't have time to answer all the questions during this program, we will get back to you with answers. Okay. Our first presentation on heat pump technology will be by Philip Hanser, who is a principal of the Brattle Group, and he has over 35 years of consulting and litigation experience in the energy industry. Dr. Hanser specializes in regulatory and financial economics, especially for electric and gas utilities. Prior to joining the Brattle Group, he held teaching positions at the University of the Pacific, University of California at Davis, and Columbia University, and served as a guest lecturer at MIT, Stanford University, and the University of Chicago. Our second speaker is Craig Foreman. Craig leads the volunteer team in Newton's Heat Smart Newton initiative. Craig holds multiple engineering and business degrees, and he spent most of his career in telecommunications and medical electronics. He was also the chair of Green Newton's Solar Initiative from 2017 until 2018. Lastly, we have Rachel White, who will speak on insulation and renovation. Rachel is the CEO of Bigmeister Design Build, a 38-year-old residential modeling company that is striving to serve as an exemplary steward of homes and prepare them to meet the challenges of the 21st century. Rachel is also a board chair of the Northeast Sustainable Energy Association. So I welcome everyone again to this program. Please visit greennewton.org and Historic Newton. These programs are supported by residents' participation in our initiatives, and of course with fundraising. All right, Phil, do you want to take it away? I'm going to stop sharing this, and you can start sharing your presentation.
Thank you very much, Marcia. I appreciate the introduction.
So your video's off. If you want to turn it on so we can see your face, it's fine, but you know.
Oh, I'm sorry.
And I think
hi.
I'm going to spotlight you.
Oh dear. My mother would appreciate that, I'm sure. So let me share my screen with my presentation and begin. I mean, I am frankly quite excited to speak about heat pumps because I think they're an exciting technology. I think, insofar as we would like to become essentially lose our dependence on fossil fuels, heat pumps are a key means by which we'll do so. So let me, without too much further, let me just talk a little bit about them. So the first question I think is that I think heat pumps are fundamental to how you can reduce your home's greenhouse gas footprint. Heat pumps use electricity. They allow you to free yourself from being on natural gas or alternative fuel, other fuels, fossil fuels of various sorts. And not just heat pumps for heating and cooling, but also heat for water heating. There are other questions that come up, about, relative to that people face around heating and cooling. I'm adding a room to my house. Should I put a radiator in it? What can I do about air conditioning? Again, heat pump will turn out to be a good answer for that. During the summer, my attic is unbearably hot and I can't use it. It has lovely views. Is there anything that can be done that can allow me to take advantage of it? We're renovating our home to accommodate my in-laws moving in, or maybe it's your children. They always complain about it being too cold or too hot. If we heat the whole house to make them comfortable, we'll boil. What should we do other than not inviting them to come stay with us? All right, so here are our examples, of heat pump technology. And on the left-hand side, the far left-hand side is a picture of a home that has a mini split system. On the right-hand side is the compressor for a mini split system. And on the far right-hand side is the heat pump water heater. Heat pumps, are great for both heating and cooling. They use heat from the air or from the ground. They use electricity to transfer heat into a space for heating or out of a space for cooling. There are air source heat pumps. That's the much more common kind of heat pump that we see. They can be installed with ducts or without ducts. They're less expensive and they're kind of a more off-the-shelf technology compared to ground source heat pumps. Those are somewhat less common. They require some space in order to basically install them, a drill rig basically to get onto your property. And they're more expensive and they require custom engineering. So electrification gets us to basically a much better position in terms of electrification. Greenhouse gases, emissions fall when I switch from baseboard, from oil, natural gas, all of them, we get reduced greenhouse gas emissions as a result. And so it's clear that when we move from oil or natural gas, we're getting rid of those fossil fuels. An air source heat pump has essentially no emissions associated with it when the fuel is renewables. And the same thing holds for ground source heat pumps. There are some basic questions, some myths that we often hear about the inefficiency of electric heat, that heat pumps don't work in the Massachusetts climate, and heat pumps can't serve as the only source of heat in a home. Electric heat is efficient, okay? There's no question about it. It's 220 to 350% efficient. Ground source heat pumps are anywhere from 350 to 50% efficient. That's much more efficient, for example, than natural gas. Heat pumps do work in the climate. There are now cold climate air source heat pumps, that can be operated full efficiency as low as 5 degrees Fahrenheit. And they have many systems that perform well at even below to 13 and 20 degrees below zero. Heat pumps can't serve as the only source of heat in a home. In 2017, about 10% of new homes in Massachusetts used heat pump as the only source of heating and cooling. They don't lose output and efficiency, ground source heat pump, even on the coldest days of the year. And there are dozens of systems installed through Mass CEC in retrofits that had absolutely no backup heat. So this is a picture of a central air source ducted heat pump system. If you have an older home, but that has a central air conditioning system, perhaps it's in the process of being needs to be replaced, or it's nearing the end of its life, then a central air source ducted heat pump system is probably appropriate. This is the picture of that ductless mini system. You can sort of see the condenser unit of the mini split up on the ceiling, and you can see it's very attractive. It's not obtrusive into the room, and you can sort of see in the diagram on the right how they can be placed all over the home. There are no restrictions in terms of where they can be placed. The typical installation involves a condenser unit. There's a kind of classic one sitting above those French doors. It in turn connects to refrigerant lines, and they in turn connect to an outdoor unit, which is the compressor unit. The components of this condenser is essentially a heat exchanger, a blower that operates behind the vanes, and then the vanes, which are used to focus where the air can go. The vanes are can operate in different modes. They can be directed in a specific way, or they can periodically rotate to, without necessarily having a specific place that they're focused on. Here's a ducted mini split system. You can sort of see the condenser unit is in this case, it's in the ceiling rafter, and the output vents are in that. You can sort of see kind of tucked away at the edge of the ceiling. Sometimes you'll find heat pumps of more than one type in a home. For example, you might do ductless mini splits on the first floor and use an air source ducted on the second floor and use the attic space for basically the ducting work. And lots of kind of indoor looks for these things. There's the traditional wall-mounted units, which we just showed you. There are floor-mounted units. There are slim duct units. There are ceiling cassettes. Here's a home where the room has got a ceiling unit and as well as a unit in the wall. So, if you currently heat with oil or propane or electric resistance and want to save on your electric bill, heat pumps are the way to go. No question, you can save hundreds of dollars by doing a retrofit. If you want to add air conditioning but don't have the ductwork for a central system, a mini split would be a great way to go. If you've got one of these air conditioner units sticking out of your window, hopefully it looks better than this one, but there are a lot of old ones out there. There's a reasonable chance that a mini split would be much preferable, a much more energy efficient alternative to this, and would provide heating all year round for you. By the way, I should point out, and I haven't done this already, the mini split systems are extremely quiet and much more quiet than the typical air conditioning unit that's sitting in a window. The mini split systems, because of the way the compressor is separated and is outside, and that, by the way, the compressor doesn't make that much noise either. But the condenser unit is very quiet and considerably more quiet than the typical window air conditioner. So, if you've got one big area to start with and you want to add over time, no need to replace your whole system. You can start with, one room or a couple of rooms and then incrementally add heat pumps to your area. If you've got a space like this attic, where you'd like to heat and cool it, this one has a mini split. It's on the wall that you can't see, but it provides heating and cooling all year round. The other part also, of course, is that it gives you great control over the temperature in individual rooms. It eventually creates a kind of zone comfort solution for you if you wish. Okay, heat pump cost. So heat pump costs are roughly about $3,500 to $5,000 per zone for a ductless cold climate system, about $10,000 to $18,000 for retrofitting a ducted system with an air source system, and about $18,000 to $24,000 for whole house air source non-ducted mini split retrofit. Other things you may need to consider. Everybody has a certain level of electrical service. Some of the older homes have 100 amp service. If you're going to retrofit your entire home, you may need to go to a 200 amp service. If you've got an EV already and you've got a level 2 charger, the chances are you've already increased the size of your electrical service. And so this won't be an issue if you're going to whole house put in whole house for your air source heat pumps. You'd like to have the outdoor compressor above the snow line. You don't want to have that picture below, which has the compressor sitting in snow. Proper insulation design is critical. Ensuring the home is well insulated with good air sealing helps you get the most efficiency out of the units. Unlike fossil fuel systems, you don't typically have a setback temperature at night like a fossil fuel system, except if you absolutely are not in the room during long periods of time. The heat pump systems come up to full speed and begin warming the room in a matter of minutes. Another way to electrify your home is heat pump water heaters. Essentially, it's the same idea as the air source heat pump. Essentially, it takes the heat from the room and it uses that to heat the water. Lots of benefits. Clearly, number one is they reduce greenhouse gas emissions by avoiding fossil fuel use. The high efficiency provides cost savings against non-gas water heating fuels. Your home solar panels can defray some of the costs of operation. It dehumidifies the space. Installing an HP, a heat pump water heater is identical to that of a conventional water heater. And heat pump water heaters now have built-in leak detection, and they'll send you a message on your phone. You can see this one is equipped with Wi-Fi. To conclude, heat pumps for space conditioning water heating can be a great way to get fossil fuels out of your homes, reduce your impact on the climate. In the long run, electrifying all of our energy uses is the best way to address global climate change. The quality of insulation is crucial to achieving the energy savings. And Craig Foreman is going to talk about HeatSmart. And HeatSmart has chosen installers who have those capabilities to do a first-class job in making sure that any heat pump system that's being installed is going to be installed well, and you'll get the benefits from it. Thank you.
Thank you, Phil. And I want to say, I'm going to spotlight Craig now. I'd like to say that thank you to Craig and Rachel for answering some of the questions from some of the attendees about Phil's talk. So attendees, you're welcome to look at the chat and the Q&A. And Phil and Rachel, if you don't mind continuing to answer some questions, that would be great. With that, Craig, you can begin your presentation now.
Okay. Marcia, do you want to take any questions for Phil right now? Or do you want to wait till the end?
I think we'll wait to the end because some of the questions are being answered in the chat. I want to remind people that if you're seeing the slide very small, if you click on the vertical line between the slide and the image of Craig and you drag it over to the right, that slide will become bigger, and we see it very well. I'm seeing it very well right now.
Well, welcome everyone. Welcome Green Newton, welcome Historic Newton, welcome Newton residents, welcome residents from anywhere. We're all here for the same thing. We're learning about one way we can help to slow the warming of our planet. And with that, we're just to review some of the things that Phil went over. Here's some things to think about when heating and cooling your older home. Think about comfort first. Are there rooms that are always cold in the winter? Are there rooms that are always hot in the summer? Those are things you're going to want to try to do better on. And we want you to think about the environment. How can you do this while lowering your overall greenhouse gas emissions? And you want to think about convenience. Are you still using window AC units? Those aren't very convenient. Think about the age of your systems. If they're getting old, everything's going to eventually need to be replaced. And think about planning for renovations or construction projects in the future. These are excellent opportunities to really make changes that can improve your overall comfort and help the environment. Now, just getting away for a second from heat pumps, these are some common problems, maybe not so common anymore with older homes. And if you have these, you should really attend to these first, because these represent health risks and fire risks. And that would be if you have asbestos insulation or vermiculite, or if you have knob and tube wiring. And if you have these, you probably know you have them, but these really should be addressed along with any, upgrade of your systems. And there are heat loan, you can finance these with heat loans. We'll talk about heat loans a little bit later. So what is HeatSmart? HeatSmart is a program that it's a City of Newton program. It's not a Green Newton program. It's a City of Newton program. We applied for and received a grant back in late 2019. The grant was for the 2020 version of HeatSmart. And it's not just the city working on this. We have very capable volunteer organizations working to help get the word out. That would be Green Newton, Newton Mothers Out Front, and 350 Mass. The goal of the HeatSmart program is really to help educate people on clean heating and cooling technologies. This program is in its 4th year. Unfortunately, it's the last year. There are going to be no grants available next year. And so we're lucky to have gotten in on this. There have been a total of 15 communities, including this year. We have Melrose and Newton this year. There's been 15 communities that have done HeatSmart programs all the way from Great Barrington in Western Mass to Nantucket. And these programs are financed by grants from 2 state agencies, the Mass CEC, which is a Clean Energy Center, and the DOER, which is Department of Energy Resources. And we really appreciate your help. We would never have been able to do this without all the help we've gotten from them. So how is this program going to benefit Newton? I always have considered it to be an educational program. We're trying to increase understanding about the benefits of efficient heat pump technology and introducing it as part of the all-electric home. And we're trying to, of course, encourage adoption of this technology in our homes. We're going to try to connect people with vetted, reliable installers that they can trust. By doing that, we're going to hopefully squeeze a little bit of time and a little bit of cost out of heat pump projects, because we're doing this with negotiated contracts that we have with our partner installers. And I'll introduce those to you in a second. We also find that homeowners often educate their neighbors about these things. And if a neighbor sees someone on their street doing a heat pump installation, they're going to ask about it, and that's going to increase adoption. It's a very important way of helping to spread these things around the neighborhood and around the city. Also, heating and cooling in the home is a key point that's discussed in the Newton Climate Action Plan. There are goals for electrifying and updating aging heating and cooling systems. So hopefully this will help us reach our climate action goals. So who are our installer partners? We have 2 of them. We have Muirfield Mechanical Services. They're based in Ayer, Mass. And we have New England Ductless, which is based in Melton, Mass. Now, we don't have any bias of one company over the other. They both can do anything that we're going to talk about here with regards to air source heat pumps. And they both really offer the same sorts of services. The name of New England Ductless has been of confusion to some people. New England Ductless doesn't only do ductless systems, they do ducted and ductless systems. So that was a little confusing to people. So how did we select our partner installers? It started off with an extensive application project that was managed by the Clean Energy Center. The installers had to submit a lot of detail about their business, sample quotes, pricing, samples of their advertising, and the CEC did a first pass review to screen the applicants. After that, a number of the applicants had worked previously with previous HeatSmart campaigns. So we were able to get feedback for some of the applicants from other campaigns. And then the HeatSmart Newton team did conduct interviews with each of the companies that we were considering. And ultimately, the CEC recommended that due to the size of our city, we have more than one installer, and we ended up choosing 2 installers. That gives people the chance to get more than one point of view, get more than one quote. And some people like that. Some people just get one and they find what they need, and that's okay. Both partner installers can do everything that Phil has talked about. That would include ductless mini splits. Could be a single zone ductless mini split. Could be a multi-zone ductless mini split. Or it could be a fully central ducted system. If you already have ducting in place and you want to replace, a system, they can put a central system in that will basically use the ducting that you have in place. Both of our suppliers can do all of these things. And they can also install heat pump, what we call hybrid water heaters, which is another technology that we're offering through our program. Now, I want to talk a little bit about aesthetics. I know that many of you have older homes. Some of you have historic homes. And you don't want to wind up with a system that looks like it's an octopus with coolant lines running all around your house. And I could show you examples of poorly done systems, but I don't want to do that. Let's just talk about first the outside. On the outside of your house, you're going to have the compressor, and there may be multiple compressors. In this case, you see two of them. Those are going to sit up off the ground. They need to do that because unlike an air conditioning compressor, these are used for heat and air conditioning. So they're going to be used in the winter as well as the summer, and we don't want them sitting in a pile of water or snow. You see a line running up from that compressor. That's taking the coolant line up to an upper level where it's being used. As far as the compressors, you have canopies. You can, if you're handy, you can build one. You can have a handyman make one, or you can buy things like as shown on the right to help keep the snow off the unit. You don't really want to put it in a spot where a whole lot of snow is going to be falling on it all winter. Some people can even tuck them in under a deck. That's a great place for it, but they'll work fine outside. You just have to, after a big snow, if you're shoveling your driveway, go and check your heat pump and shovel, any big snow buildup around it, and you'll be fine. Now let's talk about the coolant lines of the outside. And this is probably what more people worry about as far as aesthetics. And there's no way to hide them totally, but there are ways to help conceal them. And in this case, you see there's coolant lines that are running vertically and horizontally, and they're basically running in parallel with either existing, gutters, or perhaps, a white painted, edge of a house, or they're running up and near the soffit. So they don't really stand out that much. This is one way of concealing coolant lines. You don't want to just run them diagonally or in the middle where they're sticking out. You want to try to move them off to the side or near other vertical, vertical gutters and things. Here's another example where they've tried to follow the contour of the house. And so you see the coolant lines come up vertically and they shoot off diagonally along with the house line to go into the rooms where they're going to be used. This is another example of a home where the outside was actually painted an off-white color. So the white coolant lines don't really, they don't really stand out or show that much. Now, here's two examples of situations where the homeowner decided they wanted to take those coolant lines and they cover these with a PVC cover, and you can very easily paint those. If you have some house paint left over from when you last painted your house, you can go, the day before they're going to install this, they'll leave the PVC out for you, and you can go and slap some paint on them. And then when they put these covers over the coolant lines, they'll pretty much blend in with the house. That's another way to hide them. As far as the interior, and Phil went over these a little bit, but just to show you some more examples, you do have options. On the left, you're seeing a floor mounted, I tend to call these heat, they're not heat exchangers, but Phil called them condensers. People call them different things. Some people call them heads. In this case, you see a floor mounted head, and it's basically just a little fan that's forcing air through those through the heated area that's inside there and allowing that heat to be moved throughout the room. In the middle, you see a ceiling mounted unit. You would have to have attic access to do one of these because the parts of the unit that you don't see are actually located above the ceiling, which would be in the attic. And then on the right is probably the most common type, which would be mounted typically on a wall, kind of close to the ceiling. So you have options on these, and you can work with your installer to find out not only which options work for you, but where you want to place them. So how do you finance this? Well, we have these heat loans, which are 0% heat loans. You can't do better than that on a loan. And you can do this for up to 7 years, up to $25,000. They're available from many, many banks. They're very easy to get. And you can use these for any project that's going to improve your energy efficiency, including this. Now, you can't have more than one heat loan. So you've already got a heat loan, you want to do a project, you have to close out the other heat loan before you start a new one. There's also some additional benefits for low income residents with this, and there's income limits that you can actually get, some free, you actually can get up to 100% free weatherization and free heating and cooling equipment if you meet some of these household income limits. We also have rebates and tax incentives. The main one is the Mass Save rebates. And these are going to be based on the size of your installation and whether you're replacing a natural gas system, or if you're replacing what we would call a high heating cost fuel like propane or heating or electric resistance heating. The rebates are going to be $250 per ton if you're replacing gas, and they can be $1,250 a ton if you're replacing some of these high cost heating systems. There may be some caveats, like you may have to do the whole house or put in what they call dual controls. But those rebates are available to everyone regardless of income. And that's the most common rebates that we have. On the heat pump water heaters, we have a $600 rebate. Unfortunately, it's only available if you're replacing an electric water heater and it's less than 55 gallons, but it is a nice rebate if you fall into that category. There's also some other larger rebates that you can apply for through different programs offered by the Mass CEC and the Mass Save. And these can get into larger rebates, but there's a lot, you have to be doing a very large project, and there may be additional work like a blower door test or a HERS rating test. These are other things you can do, and we can help guide you on what's available and what you can use. The most common is the Mass Save rebate. We do have a federal tax credit that can be used for this or for any energy efficient change. This is a lifetime limit of $500. If you haven't used it yet, you can use it. I believe there are some income limitations on that one. So how do we get started if we want to do a project with air source heat pumps in our house? You're already started, you're getting educated, you're planning for the future. We understand that everybody's not replacing their heating systems now, but you will eventually. So having the information is very important. And if you're doing this, we want to make sure that the electricity that we're using is not damaging the environment. So if you haven't already done so, please go to our Newton Power Choice program and opt up to 100%. It's not too much money, and it's a great program. If you haven't already done one, get a free Mass Save, and most of them are done virtually right now, home energy assessment. Some of the rebates will require that you do this. Through this program, you can receive 75% off any installation that they recommend if it's a type of installation that they do. And we have a great website. I'm not going to give you the web address because you don't need it. Just do a search for Heat Smart Newton and you'll get to our website. You can learn all about us. You can see previous webinars. You can get lots of helpful information, get lots of questions answered. And there's a place, if you want to do something, there's a tab for to get started, and you just enter your contact information, and you can then request a free site assessment from either one or both of our partner installers. And finally, if you have questions, feel free to use our email. It's just heatsmartnewton@gmail.com. myself, I'm the Heat Smart coach, or someone else will get back to you and help you either through email or call you and get your questions answered. Now, this program was started in 2020. We got a late start due to COVID. So it was originally supposed to end at the end of the year, 2020. Our partner installers have allowed us to extend the program out, but there is an end date. And the end date for site visits is March 15th of this year. So that's only, another month and a half away. So if you're planning to do this, don't wait too long. And the deadline to sign contracts is April 15th. After that, the Heat Smart program, as provided by the Mass CEC and the grant that we have, will no longer be in effect, and there's not going to be a program for next year. However, the Heat Smart name and the Heat Smart program is going to continue. Green Newton's going to basically host the website. We'll have all the information there. We'll still have the same email. You'll be able to ask questions, get information, get help. The only thing is we won't necessarily have the group discount that's being offered by our two partner suppliers. We will try to work with them and get some sort of a group discount, but we haven't, gotten to that point yet. So that'll be happening, in the April timeframe. That's all I have. At this point, I'm going to stop my share, and I am going to.
Craig, one question, excuse
Yes.
me, that I thought was kind of interesting. Do Muirfield and New England Douglas also do ground source systems?
They do not. They specialize in air source heat pumps, both ducted and ductless. There are companies that specialize in ground source heat pumps. It is quite a specialized skill because they have to bring drilling rigs out and things. So they do not do those ground source heat pumps.
Yeah, ground source heat pumps are really, they are a great alternative. But there is an issue around ground source heat pumps in our area, primarily because, so in areas where you've got relatively a lot of soil, you can place the coils for the ground source heat pump easily below the line at which the ground freezes. In Massachusetts and in New England, you don't have a great soil depth. And so what ends up happening is you put in basically vertical pipes as a substitute for laying in ground pipes. And so it ends up being a little bit harder for putting in a ground source heat pump, but they're great because the difference between air and ground temperature is much more constant in the sense of, and it's easier to take advantage of.
Thank you, Phil. And now, before Rachel gets started, I just want to ask Craig and Phil if you can continue to answer questions in there
Sure.
are questions coming in Q&A and in chat. Thank you, everybody, for your questions. And here is Rachel.
Hi, everybody. Marcia, can you see my screen?
Yes.
Yes.
Okay, great. It's great to be with you guys tonight. My role on this panel, and Craig and Phil alluded to this a little bit, is just to remind everybody of the importance of thinking about air sealing and insulating at the same time or as part of your thinking about upgrading your heating system. And my guess is that, up here. My guess is that most people who are attending tonight have some understanding of the importance of air sealing and insulating, but just as a kind of helpful reminder, why should we be thinking about looking at opportunities to air seal and insulate at the same time as we consider upgrading our heating systems? Three main reasons. One is that you can achieve greater reductions in energy use and carbon emissions by looking at this holistically than by just focusing on your HVAC system. Second, and I'll get into this a little more later in the presentation, and it was also mentioned before, is you can optimize your investment in the heating and cooling upgrades by reducing the load and the heat loss from your house. You may have the opportunity to install smaller, lower capacity equipment than you would otherwise. And then probably goes without saying, but air sealing and insulating are important in helping to ensure that your house is more comfortable. So now I'm going to, Big Meister, as Marcia mentioned at the beginning, is a residential remodeling, design build remodeling company that focuses on energy efficiency and home performance. And so for most of the remainder of my portion here, I'm going to share some case studies with you of projects that we have worked on, both in Newton and elsewhere, that have featured a combination of envelope and mechanical upgrades, just to give you some sense of what other homeowners have done and what may be possible at some of your homes. So I'm going to start with this case study of a Newton retrofit that we worked on a couple of years ago. This is the existing conditions of the house, what the pre-project conditions. The house was built in 1938, had some attic floor insulation, not horribly installed, but not great either. The walls were completely uninsulated, an older gas heating and hot water system, and central air conditioning. The retrofit measures that were taken at this house were to dense pack with cellulose all the walls from the outside. And then we installed closed cell spray foam on the underside of the roof. And I believe it was Phil who talked about some of the different configurations of heat pump systems. And often when you can insulate the underside of your roof, that becomes a conditioned space that you can use to house an air handler as well as ductwork for a heat pump system. So then the entire house was converted to heat pumps, combination of ducted and ductless for heating and cooling, a heat pump water heater, and then you can see here the solar array that the owners installed. Just to give you a sense of what sort of savings were achieved at this house. I've shown the before, the after, as well as the Massachusetts average, although the Massachusetts average numbers are a little old at this point. I haven't updated those for a few years, so take those with a little bit of a grain of salt. But you see really tremendous savings in this project. And this is not a project that I would consider a deep energy retrofit, in that we didn't add insulation to the outside of the house, but rather installed within the cavities. We insulated within the cavities, but we're able to achieve really tremendous reductions in energy use as well as in carbon emissions. So now I'm going to turn to a second case study. This project is fairly typical for us in that it combines both renovation as well as retrofit or energy upgrade measures. This is what, just to give you a sense of the conditions before we did the work. Well, the house was built in 1933. The basement walls were partially finished but uninsulated. The above grade walls were modestly insulated in places. The roof had been insulated with spray foam by the prior owner. Older gas furnace, as well as hot water and central cooling. And then our project consisted of a fairly extensive renovation on all 3 floors of the house. And the energy measures were the wall insulation was restricted to the areas that we opened up and that we're touching as part of the renovation project. Unlike in the previous house I showed you, brick homes, this may be stating the obvious, can't be insulated from the outside. The walls can't, so the only option is for insulating from the inside. We also changed this house entirely over to, it's a whole house conversion to heat pumps. Again, a combination of ducted and ductless systems. Also a heat pump water heater and an induction cooktop. So this house transitioned completely off of gas. And here in this slide, I'm showing the energy and carbon savings, but it's also, I wanted to point out here, I looked also at the cost impact of doing this work. And on a comparable per unit MBTU basis, gas is less expensive than electricity. So at this house, despite the efficiency upgrades that we made to the envelope, there was a slight increase in utility costs in the first year. And I would say that based on our experience is what I would anticipate for a home that's converting from gas to electricity. If you're converting from oil to electricity, which is really not that common in Newton, I would expect that you would see operating savings, utility cost savings. All right, we're getting towards the end, so I'm going to speed up a little bit because I know we do want to have some questions. I'm going to talk, I just wanted to share an example of a project that's currently in the planning phase to give people an example of the importance of the ways in which your insulation and air sealing package can help to allow you to optimize your HVAC decisions. So this project is going to be a partial renovation and retrofit. It's a 2-family house, uninsulated walls, uninsulated basement, gas for heating, hot water and cooking. And we are going to be renovating, gut renovating the first floor unit and converting it to heat pump technology. I've made a little note here at the bottom that we are hopefully going to be insulating the basement because that is currently an area of discussion with the owner that could have a significant impact on the size of the heat pump system that we installed. And some of this has to do with the fact that in this basement, or in most basements, I should say, often in basements, spray foam is really your only option. And for a variety of reasons, homeowners have concerns about spray foam. And so we think that the walls of this basement may be, smooth enough that we may be able to use rigid foam instead. But what we've realized is we've looked at doing the load calculations for this in different ways, and that by not insulating that basement, we would likely have to upsize the equipment. And so we're, still working that out. Okay, last but not least, I want to say a little bit about embodied carbon. Unless this seem a little bit like a tangent, many people may be aware or have heard of the expression, you have to expend energy or expend carbon in order to save energy or save carbon. And so when we undertake any sort of construction project, in this case, when we undertake upgrades, weatherization and air sealing and insulation upgrades to our home, there's some carbon that we spend in order to do that. And given that we are on a very tight timeline to make really dramatic reductions in carbon emissions, we don't have endless amounts of time in order for the carbon we invest upfront in these projects to pay back. And in fact, if we continue to practice, sort of the business as usual in new construction, we'll see that by 2050, the total carbon emissions from new construction, they'll be roughly equal between the operating emissions and the embodied emissions. So even though on an annual basis right now, the emissions for building, for the materials and the construction to building is only 10%, we have very little time to waste, and so we really need to, as you say, no emission left behind, and we need to think very carefully about how we spend carbon now in order to save carbon later. And you can see this particular chart just shows the difference in the embodied carbon impacts of different insulation choices. And I mentioned a couple of slides ago about the project we're working on in Somerville, where the homeowner had some concerns about spray foam. Some of her concerns have to do with potential off-gassing if the foam doesn't cure properly, which is an issue in and of itself, although one that we feel is we know is solvable with proper installation and quality control. Spray foam is a very high, leaving all that aside, spray foam is a very high embodied carbon material. And so we need to think carefully about where we use it and try to choose what I call carbon smarter materials. wherever possible. So lower embodied carbon materials or even carbon storing materials, biogenic materials can store carbon. So the three places that we look to insulate in homes and walls, it's often easy to switch to a carbon smarter material. Cellulose is a great choice, often the best choice for many homes. Basements can be hard, as I mentioned earlier. There are often no good alternatives to foam. Attics and roofs is the place where Big Meister is focusing our efforts currently in looking for different alternatives to using spray foam to insulate the underside of roofs. And I'm going to show you, as I'm going to close with one project, just to show you an example of how we're attempting to implement a sort of carbon smarter approaches to insulation. This is a project in Jamaica Plain. Really little insulation, very little insulation when we started with this project. It's an uninsulated basement, but it's sort of deceptive. It's on a hill, so about a third of the walls are above grade. The walls were completely uninsulated, fiberglass on the floor, gas for heating and hot water, and window AC units. What I wanted to call your attention to, which is circled in red here, I've got all the measures that we took, both the renovation, the energy retrofit measures, but in the roof section, rather than insulate the rafter bays with closed cell foam, we did what we're calling this low foam approach, where we built down the rafters, started with 3 inches of low global warming potential closed cell foam, 3 inches for condensation control, and then filled the rest of the rafter bays with cellulose, which is a carbon storing material behind a smart and Intello membrane. And again, the reason you would want to insulate the roof rather than the floor of your attic is because you would be using the space, as we are in this house, for heating and air conditioning equipment. We've got an air handler up there and ductwork. So this is just one way that we are trying to be more thoughtful about the insulation choices that we're making on projects. So we are expending less carbon in doing these upgrades in order to save carbon down the road. And in my last slide, just showing comparing the embodied carbon as well as the total carbon saved out to 2030 for 3 different approaches to insulating the underside of a roof. The typical approach on the left is the all spray foam. And then we're experimenting with 2 other approaches, the low foam approach that I just described, as well as a no foam approach where we insulate at the attic floor, bury the ductwork in cellulose, and build a head house, an insulated and air sealed head house for the air handler. And with that, I realized that was a lot to throw at the end of this talk on embodied carbon. I hope I didn't, this talk to talk about embodied carbon at the very end of this, I hope I didn't totally, that wasn't too much information, but I'll stop there so we can take some questions, even though I know we're after 8 o'clock.
Going to, if you want to stop sharing, Rachel, and thank you very much. I think it was fascinating I think we need an article for the e-news bulletin on embodied carbon, would be very good, if you don't mind. Craig and Phil, thank you very much. Phil, if you want to unmute and show your video.
There
Craig,
I am.
if you want to unmute. And so you've been answering questions. We still have 88 people on this program. And so if you haven't had your questions answered, what do you think, Craig, Bill? What did you?
I'm seeing some questions in the Q&A. I can answer one of them right now. Gary writes in that the March 15th and April 15th deadlines we talked about for Heat Smart Newton are right around the corner, and it's going to be difficult to meet. How much of a group discount do you currently have? You know, it's a small discount. This isn't the kind of industry that has tremendous marketing expenses that gives great discounts to people to help them with their marketing, which is essentially what we're doing. And it's not like a flat discount. It's not like 5% or 10%. have, they've in the contract with the CEC, they've given sample prices for various configurations and they have discounted them. And yeah, when we finish this Heat Smart Newton program with the CEC, those discounts are gonna go away, but we really hope that we'll be able to work with the same suppliers and negotiate some sort of group discount. And you know, it's not a huge discount for this stuff. It's just not that kind of a business. It's not like Solo where there's all these discounts for referring people and stuff. It just doesn't work that way.
Thank you, Craig. And by the way, when Craig mentioned CEC, he's talking to Massachusetts Clean Energy Center that provided the grant for our Heat Smart program to the city. Do you see any other questions that have not been answered that
Daniel wants to have Rachel answer the question, why insulate basement walls rather than basement ceilings?
Oh, it's a great question. The typical best practice is to insulate the basement walls rather than the ceilings for a couple of reasons. One of the main reasons has to in this particular project that I was referring to, and a lot of projects that we work on, the mechanical equipment is going to be in the basement. And you want to bring that. So if we were to, in this particular project, if we were to insulate at the basement floor, for example, we would still have the same problem that the heating equipment, the ductwork and the air handler would be an unconditioned space. And so would need to, I guess, basically work harder than they otherwise would if they were within the conditioned space of the building. But that's a great question.
Thank you, Rachel. Do you see any other questions that look like they can be answered now, Phil or Craig? You're on mute, Craig.
Somebody asked the question, what does the term head house mean?
Yeah. I'd like to know that too.
Oh yeah, I was really flying through that material. So we're experimenting with an approach where we build a little room. It's not a full height room, but it's a little room for mechanical equipment. So you would open your attic hatch and you would go up into a little room where the air handler would sit. And you think of the thermal boundary of the house sort of running across the attic floor, going up the sides of the head house, over the top and back down. So you're basically bringing the mechanical equipment indoors. So the head house is not any sort of technical term. It's a term that, or maybe it is, maybe other people use it, but it's what we at Big Meister are calling our effort to create a no foam option for attics that still allows us, this goes back, it's related to the question about basements, it still allows us to bring the mechanical equipment indoors.
Yeah, I think your point seems to be, you don't want the mechanical equipment in unconditioned space.
Correct.
Because it reduces the efficiency of the mechanical equipment when it's in unconditioned space like that, particularly heating.
Yes, exactly. Yep.
Are there any other questions that you think can be answered this time, Craig or Phil?
Old house still has some moisture issues. Whoa, what's this?
Let's see, there's a question if an old house has moisture issues. So what I would say about moisture issues is let's address those first. And figure out, it could be groundwater, it could be, so I would say before you consider, many basements, and this may not be the case with yours, need some sort of drainage, like a perimeter drain and a sump pump. So I would want to understand where the water, the moisture is coming from and see what we can do to remediate that before insulating.
I see a question about cast iron radiators. So many of your older homes are going to have cast iron radiators, and some people actually like to have the ambience or the look of having those cast iron radiators, and they want to keep them around even though they don't use them. Other people want to get rid of them, and the contractors that do these installations will be able to do that for you. They'll be able to take your radiators out and get them sent to a recycling area of some sort. They'll be able to do that for you if that's what you want to do. The other thing is when you bring a new heating system in, especially with an older home, you may want to keep your legacy system there just for those really cold snaps. When we get down, below say 20 degrees, the air source heat pumps will get less efficient as the outside air temperature drops. And depending on how well your house is insulated, you might want to keep the legacy heating system, if it's working, just to give a little extra help and to keep your total heating costs down during those times when we have those really cold snaps. So some people keep them around to use them. Some people keep them around just because they like the way they look. And other people say, I want them gone. It's just, everybody has a different view on that.
Thank you, Craig. Do you guys see any other questions that could be answered?
There's a question about a ranch.
Oil baseboard. Oh, for those people, if you've got a ranch on a slab and an oil baseboard, is that oil heating with a boiler for your baseboard? Is that what the question is?
I don't see where that question is.
Yeah, he's asking, Paul is asking about.
Yeah, if it's an oil-fired boiler, right, that's basically got hot water system in the baseboard,
Yeah.
you'd be better off with heat pumps almost immediately. Relative to the price of oil, you'd be much better off with heat pumps. The other issue is, of course, I don't know what your air conditioning system is like, but if you've got a central air conditioning system, as some of the older homes do, and you've got oil heating in the pipes, you can look at the possibility of a ducted heat pump system that would give you both, improve the efficiency probably of your air conditioning system, and would provide heating. So, that's a possibility.
There's a question here about, can we use HeatSmart to help with the design of an addition? Can we use the HeatSmart team or the HeatSmart coach? Unfortunately, I don't feel like the HeatSmart coach, myself and the other coaches are really, trained well enough to help you design the system. I think the installers are much more conversant and knowledgeable about all the different options you have. There are so many ways that you can combine these things. You can combine ducted and ductless. You can combine, different systems on different floors. There's all kinds of tricks they have. They have integrated controls if you want to integrate a new system with an old system. And we can certainly go over quotes with you and help you understand them. But I would really look, as far as the design, to whoever you're working with on building your addition, designing the heating and cooling system, or get an installer in there and get their opinion on it. Okay.
Any other questions that we can answer on the spot?
Somebody, this would be for Rachel. Somebody wants to know if there's a way to tell if spray foam has been installed properly.
That's a really good, so the telltale sign would be if it's not installed properly, if there's an odor. I guess I would, if somebody has a concern about spray foam in their house, maybe they could reach out to me separately. I don't know if you're providing, or just if you Google Big Meister, you'll find a way to get in touch with me. But it's really, it's a rare occurrence for if spray foam doesn't cure properly, if it's not sprayed at the appropriate temperature or at the appropriate ratio, it can fail to cure. It's really very rare. There are some horror stories out there, and it can be disastrous when it happens. But it's if it's quality installation and quality controlled. But if somebody, I guess I would say, where I started. If you're concerned about spray foam in your house, reach out to me through our website.
Rachel, can you put your contact information, Big Meister contact in
That's
the
a good
chat?
idea.
Thank you.
I've got another one, Marcia, that somebody asked, do you advise pulling out old AC units that go through the wall or leave them as backup? Yeah, you want to pull those out. You want to cover that hole with, if it's in a window, you just close the window. But if it's in a hole, you want to cover it up and insulate it. You're not going to need those AC units in the windows or in the walls if you get a heat pump installed. You're not going to need them at all. And as far as there's a question, should we get a service contract if we just had a heat pump installed? I mean, if you're the type of person that if you buy an appliance, you always get the service contract, I would say definitely get a service contract. All the installers are going to recommend you get a service contract. I'd say it's not, absolutely necessary, but it's a good thing to do. It's not all that expensive. And there are some things you can do yourself, which will help keep it in good shape. And, you have to wash the filters out regularly. It's just, you take the filter out, you rinse it and you put it back and you keep snow around, away from them, things like that. So there's not a lot to do, but yeah, getting a service contract's not a bad idea. I would never tell somebody not to do one, but I would say it's not absolutely essential.
Yeah, I mean, particularly in your first year, you should look at the terms of the contract to see what is covered in the first year to make sure that at least 1 year's worth of service is included in the installation. Just because the time in which a system is going to show whether or not it's got a problem is usually in the first year, and that's going to show whether there's been an installation problem or not. So when you sign your contract for your heat pump, make sure that that there's coverage for any issues arising with the heat pump for at least the first year. You want to go through a heating and cooling season, preferably for the first year of installation.
And for our partner suppliers, both of them, all labor, and workmanship is covered for 1 year. The warranties on the equipment go out much further than that. It could be anywhere from like 6 years to 12 years or more. But workmanship and labor is all covered in the first year. After that, you're going to need a service contract if you want to have that.
What constitutes a zone? A zone is just it can be a room. It can be, I have a heat pump in my house. I have a small house. My zone is actually the entire first floor. I have a heat pump that basically that runs the entire first floor. So a zone is any partition, any area that you consider to be the focus for a particular unit for cooling or heating. And so it depends. Typically, a zone is a room, but for smaller homes, it can be like as mine, the entire first floor.
I'd like to remind people that we have information on these topics on Green Newton's homepage. So if you go to greennewton.org, you can connect to the a wealth of information about heat pumps, all of our presentations. This one will be up there by the beginning of next week, this recorded program. And again, Craig is the head coach of this program. He's a volunteer. Philip volunteers his time, and Rachel. All of these programs are vetted thoroughly and really involve a lot of community leaders who have expertise in their various fields, and they donate it to the community. And not just to Newton, but even outside of Newton. The idea is to head in the direction of electrification of our homes and other buildings, and to make sure that all the homes are really well insulated, air sealing, everything that we can do to take steps within our homes and our families to be much more sustainable. It's up to all of us to do that. Do you think that there are any more questions, or should we kind of draw this to a close?
I just want to say one thing that sort of reinforces what Rachel said. The first step for any of these, before you go and put in a heat pump or any of these things, is to get a home energy audit done, and make sure that your home is insulated well, and it's reasonably thermally tight. It's got to, otherwise, any of these things, heat pumps or any of these, are not going to be able to operate as efficiently as not. So the first step, get a home energy audit, find out what it takes to tighten up your home, get that done, and then immediately after that, then you can start to talk about getting a heat pump installed.
And I would like to add that a lot of people have had home energy audits a long time ago, and they're not sure really what's in their walls. So if you haven't had one in the past few years, then you might want to.
Yeah, if you haven't had one in the last 3 years, go have another home energy audit. That's absolutely the case.
Green Newton, in addition to the Heat Smart tool that we have on our website, we have a take action tool, and you can make a commitment to take various actions for sustainability within your family. Not only the energy efficiency of your home, but steps having to do with what food you eat, how you purchase things, how you get around town. There's a lot involved in this. Your home, though, uses at least a third of greenhouse gas emissions. Rachel, is that right? I don't know if that was in any of the slides, but your home is about a third, and transportation is maybe more than that. So these are what residents do matters so much in bringing down our greenhouse gas emissions. So we're each a part of it, and I'm sure that anyone who's tuned in, you know that you'll in the end save money, and you'll be helping to bring down greenhouse gas emissions for future generations. Anyone want to add anything more to, or any other questions?
Somebody just asked, I think, how to get a home energy assessment, and I believe, I would just typically send people to Mass Save unless you have Green Newton has another route.
Green Newton is partnered with Homeworks.
Okay.
So they're a Mass Save partner, and it's no cost to the energy assessment. If you have trouble finding the information for any reason on our website, you can reach out to me also with questions. Marcia@greennewton.org, MARCIA @greennewton.org. We're always happy to help people, whatever they can do for energy efficiency in their homes. We welcome your participation in any of our initiatives, our programs. If you want to become involved, we'd love for you to participate in our work. Getting a message that might be telling me to add something. Oh, I'm going to type in my email in the chat. Thank you, Mindy. So it's Marcia, good idea, @greennewton.org. And we'll answer any questions having to do with the environment.
Yes, and if you have any questions still after this, Marcia will send them all off to us for us to answer. So
I just sent it to the panelists. Let me do that again. Yes, I will. I really appreciate that each of you have devoted your so much time to share your expertise. Okay, here we go. My email contact. We really would be glad to hear from you, so don't hesitate. Any question? Somebody asked me what to do with a pair of sunglasses. I'll get to it. And if anybody knows the answer to that question, they're moving and they really care about repurposing things. So I'm telling you, if anyone has a solution for, it looks like you're working on that one, Phil. So
yeah, I can't remember. I think it's Shriners, or one of the groups collects old eyeglasses, in the frames, and they get sent overseas where people can't afford have the frames. So I think it's Shriners. I have to go check.
Also, I just want to remind people that Newton has a program that's really run by youth leaders to plant a tree to honor the memory of every life lost to COVID in Newton. And so we have information about that on our website too. If you would like to contribute to that program, that would be great. So I think with that, we're going to call this program to a close. Again, thank you for all the people who joined us. We hope you've learned something tonight, and we hope you've enjoyed it. And also, the last thing is add in, stay tuned.
And any questions about Heat Smart, you just send them to heatsmartnewton@gmail.com and we'll get those answered for you.
I'm going to put that in. You
I
have
put
all the
it already.
content. Newton.
I put that one in already, Marcia, so they got
Oh, okay. Well, one more time.
it. Okay.
For good luck. All right, everybody. Thank you
you.
again for coming, and we hope that by next year, everyone will have heat pumps technology.
Right. Everybody should be well and safe. Bye-bye.
Yes, take
Bye.
care.